Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to continue our examination of optimization of simple functions using Solver this time as our technique. So Excel has a built-in utility that can find maxima and minima functions. It can also be used to solve them. And it can do this using constraints. And so this is Solver. Okay, the approach is really very similar to when we did the bisection method of finding the zero of a function. But at this case, what we're going to be doing is looking at endpoints to see if the value is larger or smaller and using slope so that we can narrow this down and find our maxima or minima. Okay. The key things that you need to know, you need to set up the function in the form y equals a function of x, where y is the object to be maximized or minimized. And then you want to enter an appropriate starting guess for your your variable x. We looked in our previous lesson at a phase equilibrium problem where we wanted to minimize the Gibbs energy. So we had Gibbs energy as negative ln of 4 plus 216x squared minus 216x cubed, okay? And we wanted to find out where this is a minimum value. We know that we need these to both be positive, right? X and 1 minus x both must be positive, but they also must both be less than 1. And so those would be constraints that we might wish to add in this case. So if we are setting this up in Excel, we want to put our guess for x in one cell and then use cell references from another cell to evaluate the function. And then we're going to go to Solver. And if you have not installed that, let me show you. So this is the exercise we had been doing earlier. I will change this back to 0.6. Okay, so if you are doing this, look for data, and you may have Solver installed. If you do not, then you need to install that by going to Options and installing the Analysis Toolpack. So we had set this up, and let's just focus on just these two cells right now. The rest of this was used in a previous problem and is no longer necessary. So I have my guess value for x, and then here I have the function that is using cell references to evaluate the function. So it's going to only involve cell A2. So what we want to do is go to Data, Solver, and we want to set cell B2 to its minimum, right? This was Gibbs energy. I want to minimize it so I can maximize it, minimize it, or find a particular value. And I want to do that by changing the cell A2. And to change what this is, where this is located, just simply click on it, point to the cell, hit enter once you've got it selected. Okay. And then you want to add constraints in this case. I know that I need the value of A2 to be less than 1 and be positive or non-negative. So I can click this box here or not click it to choose whether I can only allow positive answers or zeros. And if I want anything else, I will add it here. So I can only do it by adding a cell. So I want this cell here to, in this case, be less than or equal to 1. But notice I could choose equal to, greater than or equal to. I can choose that it must be an integer. Don't worry about those two. We won't really be doing those. And my constraint in this case is I want it to be less than or equal to 1. Say OK. Don't want to do that, so I'm going to delete that. I had the same one in there twice, correct? Okay, but I do want to make sure everything is non-negative. I can select a solving method. GRG nonlinear is probably what you want to use The others are good too, but this one is probably the one that you want to use most of the time. And you can then just say solve. It takes a moment, and it says it found a solution, and you are then given the option of keeping the solution or discarding it and going back to the original values. Okay. Sometimes it gives a message where it did not find a solution. Usually that means you need to go in and put in a better starting guess. Okay. If you're happy with that, then say okay, and it came up with the answer 2/3, which is what we had gotten before. So now let's look at another example. And this is one that has two variables. So we're going to produce two products, X and Y. We want to know how I can maximize my profit. And the profit, after some, arithmetic, comes out to be that 60 times the number of X's I make plus 44 times the number of Y's that I make is going to be my profit. But I do have a minimum production requirement. I need to have at least 1,000 units made. And I only have so much labor available to do this. And, looks to me that, product X takes a little more time and effort to make. And so 5 times X plus 3 times Y is going to be the number of, say, hours available during the year for my team to manufacture these. So 5x plus 3y needs to be less than 8,000, and I obviously can't make a negative number of any of these. So we want to go to Excel and set this one up. So I have set this up here. So I put in my starting guesses, X and Y, and I just guessed 500. I have no idea. I put in my profit, 60 times X plus 44 times Y, and I did that so that they point to the various cells. That's important. Now, the thing that is different about this one is that the constraints, in the previous problem, my constraint was simply that the variable needed to be less than 1. Here I have more complex constraints. They involve mathematical expressions using both variables. So constraint 1 was about B1 plus B2, and it needed to be greater than or equal to 1,000. And our other constraint was about the labor, and it said that 5 times X plus 3 times Y needs to be less than or equal to 8,000. So I set the algebraic portion of these up, okay, as a cell. Again, using cell references back to the X and Y first guesses. Then I'm going to go to Solver. And in this particular case, I want to set my objective that my profit here, cell B4, is going to be a maximum. I want to maximize profit. I'm going to do this by changing cells. Well, I have two variables. So it's going to change both X and Y in this exercise. So if I just do this, it'll just try and find the maximum of all values, but remember we have these constraints. So I set this up so that cell B6 needs to be greater than or equal to 1,000. Cell B7 needs to be less than or equal to 8,000. Okay. I do need everything to be positive or 0, so non-negative. So I click this box and say solve. Okay, and again, it found a solution. Actually, really didn't find a solution, or did I click the wrong button? Okay, solver. All of these things here. Yes, yes, yes. Okay. Oh, I didn't point out this. Options. Notice on options, I have the choice of changing scaling, changing the number of iterations, or making it show me every calculation along the way. I can choose whether I'm going to use forward or central differences on the derivative estimates. I can have it every time it gets to a corner, do a fresh start, okay, to make sure it's really getting to a global maximum. We are not doing the evolutionary, so don't worry about that one. And then say okay. And then solve. And really not sure why it's not showing me the answer. This is very weird. It did show me the answer just a moment ago. But this should, when you say okay, take you and show you what the answer is. Let's look at that sheet again. So solver, B4, maximum. Oh, by changing cells. That's what I did wrong. I replaced those. I choose the two cells that I want to change, my X and Y. There we go. Now my constraints are in there. Whew. All right, and this time it did give. It changed my answers. All right, and so it says that you should only make product Y and not make product X. Okay, so that concludes this lesson, complete with a little, why did that not work moment. Anyway, thank you very much for your time, and see you in the next set of lessons.